Hello everyone, and today is the second Open Zemi of our evolutionary computation group. In this Open Zemi, the students and other friends of your study group will present their research topics. Today, Yifan He will present his research on knowledge-driven programming synthesis. So, Yifan, please feel free to begin.
Okay, so I'm going to start. So hello everyone. Today I'm going to introduce my research topic, knowledge-driven program synthesis. So actually here you can see an illustration. So an agent is going to write some program and he feels very confused. And his friends are going to look up for some knowledge from books. And this is what we are going to talk about today, the knowledge-driven program synthesis. And inside this presentation, we will go through the following topics: the program synthesis, the problem we want to study, PostGP, the method we use, and the idea we're going to propose how to use knowledge, and also some future plan, like where we can get knowledge and more further open questions. Okay, let's start with the first topic, program synthesis. So why we need program synthesis? In short, program synthesis means to build a program that can write programs. Of course, the first perspective is from social needs. We know that computer programs, they are fast, accurate, and automatic. People use computer programs to do a lot of things like engineering, scientific research, financial stuff, a lot of things. But unfortunately, people who write program, we call programmers, they haven't benefited from the above features. So we still need a lot of human resources to write programs. And we find that humans make a lot of bugs during programming. So we do see a huge demand to build a program synthesis technique. Another perspective is more exciting. Say program synthesis is actually a practice of artificial general intelligence. So by say artificial general intelligence, it is really just a strong AI which can think as a human. We know that programming is very difficult. It's about understand and solving problems. So we may think that study a general program synthesizer is actually a way to learn how we can achieve artificial general intelligence. Okay, but what is really a program synthesis? First, we know that program is actually a sequence of instructions. Below I give you an example of this-like program, which is A plus B. And we all know that this sequence of instruction can perform a specific task. And we can describe this task, use our natural language, add A and B. But we can also describe in other ways. For example, we can use IO examples. For this program, if we give inputs 1 and 2, it should return 3. If we give input 2 and 3, it should return 5. And this IO examples is exactly the way we are going to describe tasks inside this research. And for the word synthesis, it really means to generate. And inside this study, we are going to generate program by using search algorithms. You may know that it's called genetic programming. But program synthesis is really a large topic. There should have a lot of alternative methods. I'll provide a recent one, which is based on language models. So language models, you can think it's to say, given a sequence of tokens and you are going to predict the next token. The recent application is GitHub released a tool called GitHub Copilot. It is something like auto-completion of code inside your IDE. Okay, so this is a brief introduction for program synthesis. And inside our study, we are going to do example-based program synthesis through a search algorithm. So in detail, we are going to search a sequence of instructions to satisfy a set of I/O examples. So here by say satisfy, I mean we are going to solve the following optimization problems. We are going to find a program P, and this P is actually inside a search space called pins. This search space is defined by a given set of instruction called ins. And the objective function is actually a sum of several error terms. For each error term, we are going to calculate the difference between given outputs and the actual outputs we get. So the actual output is actually run the program P with given input I. Okay, so this is the mathematical formulation for our example-based program synthesis. But I will give you a simple example to help you understand it. So say we have a task. I will give you the instruction set. We have two inputs, X and Y, some operators, and a constant 1. And we are going to search a program so that it can pass the I/O examples. There are two examples. And in each example, the first two numbers are inputs. The last one is output. Let's write our first program, which is X plus 1. So the error of this program is actually easy to calculate. When we have X equals to 1, the actual output is 1 plus 1, so the error is 0. And we can do the similar thing, and we know the total error of this program is 3. And we also can write another program, which is X plus Y. We can calculate the error similarly. And we know that for this program, the error is actually 0. So this is exactly the program we want inside this example. Okay, so this is the introduction for the program synthesis. And then let's go to the next topic, which is the method we use called pushGP. Okay, so pushGP is actually a genetic programming algorithm based on push language. First, push language is a stack-based language, and it is Turing complete. So hereby say Turing complete, it means that with this language, we can generate all possible programs. So with push language, the program is actually a list of push instructions. And when we execute a program, we are going to execute instructions sequentially. When we execute an instruction, we are going to do two steps. First, we will pop the arguments we need from the stacks. For example, if you want to add two integers, then you need to pop two integer arguments from stacks. But we will skip the instruction if there is not enough arguments. And after we have the output, we push it back to the stacks. So let me show you a simple example. Here we have a push program. The first instruction is to compute the string length. As we know, we need a string argument. So we pop the first string from the stack. And we know the length is 5. So we will push 5 back to the integer stack. So this is basically how the push language works. Then we are going to talk about genetic programming. It is the method we use to search a push program. It is actually an evolutionary algorithm that's designed to generate programs. And GP is a large group of algorithms. The most simple one, the original one, is based on tree data structure. But for our push GP, as we know, the encoding of solution is actually at least. So basically, I will represent the individual or the solution of push GP using a list of blocks. So you should know each block is actually an instruction. And the variation we use in push GP is called addition and deletion mutation. It is very simple. When we do addition mutation, we are going to copy each instructions. But before we copy an instruction, we have probability to insert a random instruction. So here you exactly see we insert a random instruction before we copy the third one. And the deletion mutation is even much simple. We have some probability to not to copy an instruction. Okay, so this is how the push GP works. And there are some advantages of push GP compared with other GP algorithms. So first, push GP is more expressive because it uses a Turing-complete language, which means it can generate any program we want. And second, we know that push GP use multiple stacks to handle the different data type. And we know that if the argument is not enough, we can skip the instruction. So basically, we know that even random programs are syntactically valid. This is a very cool thing because in program synthesis, we have to consider syntax. And syntax is something like constraint. So which means you need to design variation operator, consider constraints, or you need some extra effort to design repair operator. But with push GP, we do not need to do that. So these are two advantages of push GP algorithm. Okay, now we are going to move on to our proposed ideas, how to use knowledge. Our motivation is very simple. First, search based on the IO example only is not very efficient. And when we look at how humans do programming, we find that human uses knowledge during their programming. So we are going to think, how can we do similar things when we use push GP? So first, knowledge is actually information about the problem or the information about the solution of problem. In the literature, there are some implementation of knowledge. For example, there is a work, they will give the frequency of instructions to define the genetic source. But we are going to implement knowledge in a different manner. We are going to define knowledge as a part of solution, which means knowledge is a subsequence of instructions. In fact, we do similar things every day. For example, when we do programming, we are going to import a lot of libraries like NumPy, Pandas. And this is exactly we want to add to our push GP algorithm. So let's see how I implement this idea. The method is called insertion mutation. It is very simple. We are going to insert a partial solution during the evolution. So here you can find this long rectangle is the solution we want to mutate. And this short block is actually a knowledge, a partial solution we selected randomly from an archive. And we are going to insert it at a random place in the original solution. So this is basically how I designed to inject knowledge with PushGP. So although it is not detailed, but some experiment results shows that we can improve PushGP by inserting some human-made partial solutions, which means if we have right knowledge, we can improve the results. But then I'd like to talk about some future works. Where can we get knowledge? It is very important. So in the literature, some people try to find knowledge from textual description of programming tasks. In that work, they hunt the keywords that map to Python built-in functions. They hunt constants, operators, and what not to use based on text. So the way they hunt knowledge is do by hand or some simple matching rules. And another way in the literature is try to find knowledge from similar problems. So they call it the transfer learning for GP algorithm. Inside that research, they prepared 25 program synthesis problems. They collect instructions from the solutions of 24 problems and use this set of instructions as genetic source for the rest one problem. And of course, they will include some problem-specific constants. And as a result, they find that with transferred genetic source, the result can be improved on 8 problems. So this is two related work in the literature, but you should know that they are all doing things with single instructions rather than partial solutions. So now I'm going to talk about some possible future works. The first one is we can consider how can we extract knowledge from previous solutions. We may start from extract random partial solution. Another way we can try is to see whether there are some common partial solutions. And also partial solution with some special pattern might be interesting. Another way we want to try is how can we use knowledge in a better way? As we know, we now choose knowledge from the archive randomly, but we can do the following things to improve. For example, we can consider the correlation between partial solutions. Some partial solutions, they might appear together. And we can also do adaptive probability to select the partial solutions, which means a partial solution that can improve the results we want to use more. So of course, we can also mutate partial solutions. And so this is the probable future works that we want to try. And then I'd like to move on some further questions, the open questions. Let's imagine if we have a server and we run a GP continuously, and we threw a lot of problems to it. And once it solves a problem, we extract partial solutions. And we do it again, then we have a large amount of knowledge. So then it is very like a human is study programming through a lot of programming problems. we will have several detailed problems we want to solve. For example, how to decide whether we remember or forgot a knowledge or not. And since there really have a large amount of knowledge, we may want to design a way to store or index or search a knowledge so that we can access it quickly when we want to use it. And finally, we may want to try how to create new knowledge based on some existing knowledges. Okay, so this is the open questions I want to discuss with you. And I list the references I used inside these presentations. And okay, this is the end of my presentation. And it's time for you to discuss and ask questions.
All right. Thank you very much, Yifan, for your very, very nice presentation. So now we are going to open for the times for questions. So in the OpenZemi, we have a few of the other students in the laboratory in the Zoom call, and we're going to ask them for collaborative some questions. And for those of you that are watching this presentation on YouTube, you can add your questions on the chat, and I will add those questions. I will ask those questions to Yifan as we progress. But first, I would like to ask the current students. So, Yuri, would you like to ask some questions for Yifan about his presentation?
Yes, thank you for the presentation. It was nice seeing your work. There were two things that weren't clear for me. The first one was how do you define knowledge, and the other one is how do you define partial solution?
I see. So inside this research, knowledge is actually a part of solution. So we know that the solution in PostGP is actually a list of instructions, right? So here the knowledge is really just also a sequence of instructions. So in the experiment, we can get partial solution as a slice of the solution from another problem. Is it clear for you?
Yeah, thank you. And that was all. Thank you very much.
All right.
Thank you for question.
Thank you, Yuri. We have a question from the chat from Pirofu, and he is asking, what kind of domains have this approach been applied to, or what kind of domains do you expect this approach to be applied to?
Thank you for your question. Yes, currently I am trying the problems in the benchmark, the general program synthesis benchmark. And actually, I will say if we have a correct knowledge, I expect it should work in a lot of programming problems.
But do you have, like, for instance, for your personal preference, is there anything that you would like to apply this to if this worked correctly?
Currently, I did not have a specific preference. But maybe in the future, I would like to try designing optimization algorithms using PostGP.
That's a very good idea. Peter Fu gave this suggestion because he works with video games and he wants to use this for generating mechanics in video games. When I was thinking about PushGP myself and program generation, One of the first applications that I thought it was a little bit of like a fun idea is to generate a programming competition, a participant, computer participant in programming competitions, like a robot that can participate in ICPC. All right. So let's see. So next, Abe, do you want to ask any questions to Yifan?
So my question is a bit similar to Yuri, but the thing that I'm a bit I cannot still cannot imagine is how do you know that this sequence of comments is a partial solution?
Um, what do you mean by is a partial solution?
So basically, you said in the later slide, I think it's almost the end. You said that if you run it in a server that all the time, and it will collect information and make it a partial solution, right?
Yes.
Uh, but the and by having this number, this a lot of this partial solution, you can evolve it. You can do the evolution better because you have other or predefined. But how do you define that this set of comments that was generated during the evolution is uh, is a partial solution?
Hmm. I think this is a very good question. I think one simple way is say, if we inject this partial solution, then the result is improved. We might say it is a partial solution for the real answer. So what we can do during the evolution is we can try some adaptive things. We of course have an archive of partial solutions, and we start from equal probability. And once we insert a partial solution, the fitness improved, and we can increase the probability to apply that partial solution. This is only one way to do that.
So
It,
basically, the idea is uh, to to use a candidate. You decide a set of line as a candidate and use it on different kind of different iteration or different case. And by having if this keeps on improving all the other on this during this test, that this is more and more likely to be a partial solution, something like that.
I think, yes.
Well, okay, that's clears it a bit. That's all from me, actually.
Thank you very much, Abe. I think Abe's question is very important for a very different reason, Ifan. Because if I'm correct, one way that you can interpret Abe's question is that if someone hears the word partial solution, maybe they can understand that a partial solution is actually something well defined. Like if you have, if you're trying to calculate a let's say the solution to an equation, like the zeros of an equation, a partial solution can be one of these zeros. While maybe in your idea, the partial solution is something that is much more abstract. It's not a solution in terms of an answer to the problem, but a solution in terms of a candidate solution. So a partial solution can be anything that could possibly contribute to the final solution. So maybe you need to think about how you're going to introduce the idea of a partial solution so that this distinction is clear.
Yes, thank you for the suggestions.
Okay, thank you very much, Abe. Fabio, do you have any questions or comments that you would like to make?
Yes, I have one question. First, thanks for the presentation, Ifan. And I want to ask, when you use knowledge from the partial solutions, how do you evaluate the GP since you don't have the complete solution?
Sorry, I did not get the meaning of the
Oh, sorry.
questions. What do you mean by evaluate GP?
You presented in the beginning how to evaluate GPs using that error function that's for inputs and outputs, right?
Yes.
But when you are using partial solutions to build your program, do you have these inputs and outputs?
Yes, we have input and output. So knowledge is like assistance to make the search much more easier, but we still need to calculate fitness based on the given input and output.
Okay, so you need this set of inputs and outputs independent of what you're using.
Yes.
Okay, understood. Thank you very much.
Thank you for the question.
Thank you very much. Thank you very much, Fabio, for the question. And I saw that Roman just joined us here in the Zoom call. Hello, Roman. Roman, I think you're mute.
Yeah. Hello, everyone.
Did you manage to catch the presentation?
So unfortunately, not entirely, because I thought it was 9 a.m. UK time, but actually it was maybe 1 hour later.
Oh, okay. Yes,
earlier. I mean,
earlier. Yes, maybe I did not give a very good announcement in the Slack. Sorry about that.
That's all right.
Did you manage? But if you managed to get a little bit of the end, do you want to ask? I saw that you commented on your Slack about GitHub Copilot, and I don't know if you saw that Yifan was talking about GitHub Copilot in his presentation as well.
I did not.
Yes, I found it a very interesting coincidence, like as an example of a kind of thing that is program synthesis. So do you have any comments or questions about the presentation or the discussion after the presentation?
No, I don't have any questions.
Okay, thank you. What about you, Jair? Do you have any questions or comments about Ifan's presentation?
I also got up late, so I missed the presentation. I don't know if this was answered during the presentation, but I was wondering if those pieces of solution that he inserts, if he computes like a fitness for those pieces, or it's for the whole individual that he's evolving. For example, if he has 3 candidate solutions that use those pieces, he can get maybe average fitness for that piece. Did you understand, Yifan?
Yeah,
do you compute the...
Well, we are not going to compute the quality of these pieces. Right now, we are just insert them into the solution. So we are not going to evolve these pieces. So the fitness of pieces are not evaluated, but the fitness of solution is computed. Is it what you are going to ask?
Yes, I was wondering that maybe by evaluating them, you could have an idea of the useful pieces or not after a few generations, or that they are used.
Yes, I think this is a very good idea, and this reminds me about like some research in, I'm not sure whether you know, it's like virus GA. They have similar studies. Yeah.
Oh, I see. Thank you. That was my question.
Thank you for your comments.
Thank you very much, Shair. ハクロさん、何か質問とかコメントありますか？
はい。一つお聞きしたいところがあります。16ページのこの3つ目、Hand by Hand and Simple Matching Rules。ここのルールは、ちょっと、もう少しお聞きしたいと思います。
Oh.
はい。
I see. So the problem is, what does it mean by simple matching rules here? So unfortunately, I did not know the detail of this simple matching rule because they did not describe in the paper, and I cannot find the like open source code for this research. This is
なるほど。
まあ、
はい。わかりました。ありがとうございます。
それは残念でした。はい。白露さん、ありがとうございました。Okay, Yifan. So that is everyone in the group, and we don't have any extra questions from the chat. But I would like to make one final question, not directly related to what you presented, but related to your research area. This morning I made a small presentation about evolutionary computation, and I explained a little bit about GP. And one of the persons hearing to my talking this morning made a very interesting question, and I want to ask you the same question. The question that they made to me is like, if we manage to get a computer that programs really well, like a GP, what would be the relationship between programmers and this computer that can program, in your opinion?
What do you mean by it can program very well? Is it really like it's programmed as a human?
So I mean, so we are creating we are trying to create a program that can program, right? We're trying to create a computer program that can create other computer programs. If we manage to do that, do we still need programmers, or what is the role of programmers in that case?
I think this is a very good question. In fact, I think one thing difficult in program synthesis is how can we describe a problem to a computer. And if we really have a very strong GP, I think maybe the work for human is to find a proper way to describe the problem to our computer.
Yeah, this is something that I thought that you would say, because that's one of the initial motivations of your work, right?
Yeah.
Yeah, this is not a simple question, and it does not have a simple answer, but I think it's a question that it's important for you to think as you continue on this research, because more generally, this is the general question of the relationship between automation and humanity. So it's something to be always aware of and to think about. So I just wanted to introduce this question. I think it's an important question. All right. So thank you everyone that asked questions in the group. Thank you everyone. Thank you Pirofu for asking your very interesting question and for joining us. So this will be the end of the live stream. I expect to have a different presentation from another student in 2 weeks from now, and I hope you can join us there. So bye bye everyone. All right.